we have a few new people, so we will go through the goal setting and the solution in a bit more detail. Then we have Q&A on the recommendations, where we're particularly interested in learning where you would see problems in adopting it, because that's what our mission now is, helping institutions adopt the recommendations, helping solve problems, and see whether there's any new challenges that we have to face that might require some adaptation to the recommendations. And then we'll hear from Reina on a new update on their implementation of the recommendations. I guess the most comprehensive implementation that we've seen so far, the most comprehensive framework and largest data infrastructure implementing it. So I'm very curious to hear what's new there. And then we'll see some new challenges from another working group that is being, or is an interest group that is being launched now on complex citations. So, oops. Oh. No. Somehow. Yeah, but I don't see my slides here now. It's not good. Share screen again. No, we need to share the screen again.
Oh, in Zoom.
To go to the Zoom session and share the screen. This one.
Yes.
And we're back to screen sharing. And now it works. So, welcome. That's the easy part. Short description of what we were trying to do. There was two problems that the working group set out to address in data citation, or as we would reactively actually label the working group, data identification, precise identification of data. The two problems that we have is that a lot of the data that we're dealing with is inherently dynamic. And dynamic can mean it changes by the millisecond with new data coming in from a data stream, or it can be an update every now and then when somebody's working with a data set, finds an error in the data, goes in there and corrects even just a single error. Or it can be a recalibration of an entire data set in a batch process, any changes that happen to data. Now, if we want to support reproducibility, if we want to be able to go back to the state that data was before, that makes it hard. That's hard to realize with conventional approaches. So the approaches that you see in practice is either you identify a data stream and you write down, I downloaded the data on the 15th of January last year, which is brilliant information, but not very helpful at all unless you package this information with a time machine that allows you to travel back to the 15th of January and do the download again. Other approaches that we've seen is wrapping data and storing basically dumps of data. So you store the dump of the 15th of January, you store the dumps of the 15th of February, 15th of March, or you do quarterly or annual dumps. That's the most common workaround, so batch releases of data snapshots at given points in time. That works in principle. The downside is that, first of all, you have a lot of redundant data being stored in those snapshots. So it's not particularly efficient, especially not for large scale data. But in my opinion, a much more severe downside of that is that it delays the time until you can start working reliably with data. So if you have annual snapshots, you can't do any work on current data that's reproducible, that's can be replicated, that can be reused, until the new snapshot has been made available. So if you have an annual release on the 1st of January, the next year you work with last year's data, but you can't do any work on current data. And what we would like to have is a solution that allows you to work with data at any given point in time. And when you discover something, cite that specific state that it was in. And it doesn't matter whether we are talking now milliseconds or daily intervals, monthly intervals, or random updates. Okay? So you work with live stream data, you publish a graph, you want somebody else to be able to reproduce that graph or work with exactly that data using a different algorithm. or just verify if something went wrong in the process once you find out that the result of a computation was not leading to the expected results. So that's problem number one, really dealing with the dynamic states of data. The other thing that we were facing as a problem was the granularity of data. We have massive data collections. It's very rare that researchers work with the entire data collection as a whole. Usually you select a certain subset. That can be rows and columns in a table, that can be regions in a map filtered by certain criteria, can be delineating a boundary on whatever, an X-ray image. That's the part that you're working with. And what we would want to have is an efficient and easy mechanisms for researchers to identify the specific subset of data that they were working with. And again, we took a look at how things were being done in practice in the literature. When one thing is you select your subset, you download it, you zip it and upload the zipped file with the specific subset that you were working on. Again, that works. It's a nice workaround, but it leads to lots and lots of zipped data files being uploaded redundantly. So not very efficient. The other more common approach is that in the methods section of the paper, you describe what kind of data you downloaded from a database. So saying, okay, I downloaded those measurement stations, those attributes of all data collected between the 15th of January and the 25th of March. And that led to 15,229 tuples that I feed into my analysis process. Now, those of us who have been trying to reproduce that and set the filters accordingly to get exactly to the same 15,229 tuples will recall that this is sometimes quite challenging because you get somewhere near that number of tuples, but hardly ever precisely to them. So it's a nice intellectual challenge. Call it a weekend puzzle for scientists, basically. Simply because natural language descriptions are not sufficiently precise. They say 15th of January until 25th of March, is that including or excluding those 2 days? Open or closed intervals? Hardly anybody's writing open or closed brackets in a paper, natural language description of the method section. And forgetting to describe filters that are obvious to the researcher who filtered the data, but not to the one having to reproduce them. We had ideas, or there was proposals of assigning an identifier to each row in a data set so that you could identify which rows were selected just by citing the entire 5,000 rows, which makes for very clumsy representations. Plus, you also have the selection of the attributes if we are now talking just tabular data. We even had once the proposal of putting an identifier to each cell in a data set and then citing the set of identifiers. That's usually larger than the data set that you want to cite in the first place, so not a very convenient idea. So what we wanted to come up with a solution that allows you to identify any arbitrary subset of any type of data at any given point in time. So that was the mission that we set ourselves. That was back in, well, I guess the first, we would call it a BOF session now, the first informal meeting of what were to become this working group actually happened 10 years ago in a lobby corner where 5-6 people were sitting together and pondering some of these ideas. It took some time until we then had finally a charter and a working group established. But from 2014 to 2015, we were basically coming up with some recommendations of how to address these problems. And the solution shouldn't require any rocket science, but something that's easily and widely available. We then presented the final results at P7 in Paris. And then we waited for another year before we asked RDA for endorsement because we wanted to make sure that whatever we proposed actually holds up to expectations so that it was implemented by some data centers in operation so that we know that it really works. Because on paper, things look so beautiful. Once you implement them, you get to learn the really nasty bits. So, and here we are basically since 2016, just talking about what we've been deciding years ago and hearing back from others who have adopted it and hoping to hear from new challenges where you think it might be difficult to adopt. So, talked about the problem, let me briefly present in a nutshell the solution. We have data, and when I say data, I will frequently use the terminology of relational databases, so tables with rows and columns, but basically it applies to any kind of data. It can be files in a file system, can be images, can be maps, can be multidimensional data cubes, can be triple stores, can be graph databases, can be RDF statements, any kind of data, can be text, can be free-form text. So we have any kind of data, and we have mechanisms to access that data. So on a file system, you can do an ls command or a dir directory browse command. On a relation database, you have your SQL, your SQL query. In graph databases, you have your Sparkle queries. On maps, you can draw bounding boxes. On X-ray images, you can draw ellipsoids or a nice thing around whatever you want to mark as a lesion, for example. That's denoting a subset of the data. Let's call that a query. Can be a Sparkle query, can be a SQL query, can be a bounding box coordinate query, can be a query against the file system. We have data, and we have a way to query, filter, select from the data. The solution that is being proposed is to identify and cite data dynamically via the query. And here is where the dynamic data citation label of the working group actually comes from. It's dynamic data that we want to cite, and we cite it dynamically via query. How does it work? If you have data that changes, and if you ever want to go back to an earlier state of that data, the only way to do that is to have that data versioned. Versioned means when you add, or versioned and timestamped when you do the versioning. So when you add new data to your data source, new files arrive, new measurement values arrive, they arrive and you put in a timestamp when they arrived in your database. When you delete something, don't delete it, because otherwise you can't go back to it, but mark it as deleted with a timestamp. If you find an error in your data, don't overwrite it and correct it, but mark the old one, incorrect one, as deleted and reinsert the new one with the timestamp. That's something that's pretty much standard technology in most settings. You can version file systems, you can version SQL databases, you can version graph databases, you can version data cubes, binary data streams. It is sometimes more challenging than in other settings, but it can be done. And if you want to go back to earlier stages, keeping the earlier stages is the only way of doing it. Now you have researchers creating working sets via some form of interface. That can be face-edited browsing, it can be a graphical interface where you draw boundaries, it can be an API where queries come to a system. What you then do is you store the query with the timestamp of executing that query on the system. So you have a timestamped and versioned data source, you have a timestamped query. Given those two things, you can always recreate the same data set from that data source again. And that's what we assign a persistent identifier to. So that for the user, it's completely transparent, but for the system, the persistent identifier points to a landing page that basically in the background has the query string that can be hidden. The user usually doesn't bother about SQL query strings. But when you then say download or reactivate, give me that data set again, that query is being re-executed and the data set is being delivered. So those are the two key recommendations. There's a few other ones on rewriting the query so that you get standard sorting. There is the recommendation to put in a hash key for verification of the correctness of results, recommendations on the landing pages. But basically what is important for us is that that solution doesn't require the researcher to change anything in the way they behave. It's purely a solution that is provided by the data infrastructure. Data infrastructure takes care of the versioning and the timestamping. The data infrastructure stores the query. The researcher works as usual. They select their subset. They do narrow down the subset until they think they have the correct one. And when they click download or send to supercomputer for processing or whatever else, then that query is being stored with the timestamp of execution, hash value is computed. The only thing that changes for the researcher is that they get the data and they get the persistent identifier, a DOI, URI, whatever you want to use as a persistent identifier system. Anything that's a widely adopted standard. And the citation text as a text snippet so that the lazy ones can just copy it into the paper to encourage citation. there is a few nice benefits that this solution has over all the other ones of storing dumps and zip files. One is that having the query string, you have extremely detailed technical metadata of what the subset actually was semantically. No matter what you write in your method section of the paper of how you think you filtered the data, the query string contains the information about how you really filtered the data. What we actually want to point to is now, I guess with ChatGPT, you can turn the query string into a nice textual description for the method section very soon. So it saves further time for the researcher in writing the method section and paper selection. The other nice thing is that when you have the query, you can re-execute the timestamp query against the timestamped database and get exactly the same subset as it was at the original time. But you can also rerun the same query and get a semantically identical data set, but benefiting from all the additions, corrections that have been happening since, all the quality improvements. So if you've done a study a year ago, and then somebody did some quality improvement on the data set, you can just rerun the same query, you get exactly the same data set, but quality improved, so to speak. And you can compute differences in any outcomes that you have. And last but not least, by analyzing the query store, a data center knows which parts of the data set are used for which kind of study, so it gives you a better overview of, on a much more fine granular level of detail. So those are the recommendations. There's a few other details that I don't want to go through now in the presentation, but we want to avoid that the same query is being executed twice at the same state of data and given two different identifiers. So there is a little bit of work on how to make queries unique. Some databases, or many databases, are set-based, not sequence-based. So running the same query twice always gives you the same result set, but not necessarily in the same order, guaranteed. So there are some recommendations of what you want to do to ensure that the data is always sorted in the same way, so that if you really want to run it then in a processing pipeline to guarantee highest level of reproducibility. Something on hash keys. We had some discussion on timestamping, what timestamp to apply. Those are all subtle details that I don't want to go in through now. When resolving a persistent identifier, so when a user clicks on the DOI or the ARC or the URI, whatever, person is taken to a landing page. On the landing page, you have whatever metadata should be published with the subset of data, and if possible, a link to reactivate or rerun the query and download it. And it should have a machine actionable interface so that it's not just a human who can understand the landing page, but machines can understand the landing page. And then one of the questions that came up very early on is what happens if we change our data infrastructure? We move from MySQL database to a NoSQL database or to some graph or triple store. Well, if you migrate to a completely new data environment, you migrate the data and you migrate the queries that identify the data. And assuming that the new representation doesn't lose semantic granularity, you will usually be able to find a mapping so that queries can be translated. And we've done some studies on that already for schema evolution in databases, moving a file system to a database, things like that. Of course, those are not projects that run overnight. I mean, those are infrastructure migration is a major initiative. Then we were actually done, but people were not happy with 13 recommendations. That was felt to be an unlucky number, so we added a 14th one. If you do that, check that it actually works, which felt like a good last addendum. The whole thing is published in a single leaflet flyer that's linked up there, that has the recommendations and a short explanation of the recommendations on the back side. So that's the most compact representation that we have. There is a slightly longer report that we published immediately after. And there's lots of reports and webinars on institutions adopting it. And then there's a paper that I'll hand over to Mark a bit later on. I'll hand over to you right now, that describes all the adoptions and lessons learned from over the years that we have been running that working group.
Right, thanks, Andy. So yeah, here's the paper. There's the reference to it. Andy calls this our magnum opus. It's a pretty substantial paper. And what it does is it goes into a fair amount of detail for about a dozen adoption scenarios and a quite diverse adoption scenario. So if you're thinking about adopting them, highly recommend you read this paper to learn from the experience of others. Okay, this is beyond the paper, but well, we do discuss some of this in the paper, so that there are, it's been adopted by a number of data centers and archives, but it's also been adopted in a variety of standards and guidelines. It's not explicitly mentioned in the Joint Declaration of Data Citation Principles, which I'm hoping you all are familiar with, which are very high level, but what we're really addressing is Principle 7. So I think it's important to note that we're really focusing on the specific and verifiable notion of citation and enabling reproducibility. We explicitly avoided the credit question, which is, there's a lot we try and do with citation. There's many things we try and do with citation, and we're really focusing on the reproducibility aspect. Credit is a complex beast, which we can talk about, but it's something that we really tried not to address in great detail. The Earth Science Information Partners, a group in the US, has very detailed data citation guidelines, specifically for Earth science data. I led that group, so I'm biased. I think it works for more than Earth science data, but it explicitly recommends that using this approach for dynamic data. And it's also been adopted as an ISO standard for bibliographic reference and citations to information resources, which is cool. I don't remember what PS5 technical specification is. Does anyone know the status
still
on that?
pending with the European Commission. It's a
I know what
standarding
that
initiative,
is.
and
Yeah.
the Commission it has been approved, but it has never been published officially and released. So, I'm not
So a
sure
number
what
of,
the status is.
Hillary Hanaho, our current Secretary General back in the day, managed to get a number of RDA recommendations adopted as formal European Commission standards. And what you just heard the status from Andy is where it is on this one.
Just a quick comment. If you're worried by the P's in the brackets, those are the plenaries where the respective stuff was being presented. So since all the slides are back in the repository, if you want to look up any of the whatever ESIP or ISO 690 presentation, you'll find them in the slides of the recording, the respective plenary.
And remind me again what the data site considerations are.
We had a discussion with DataCite on whether they would adopt that within their schema. So we had a discussion whether identifying a subset of a database would be a subset identifier within a DOI identifier. And then we had some discussion and agreed that would get just a unique identifier because the subset would add semantics to something that might change because data infrastructure might just split up even, go to two different institutions for different parts of it. And so we decided to have a pure DOI in this case for DataCite for an entire subset for a query.
Okay, thanks. To be clear, I became co-chair long after this was all done, and so I don't remember, I don't know the history nearly as well as Andy. So then also in the paper, we discussed a number of reference implementations, sort of at an abstract level, but as Andy talked about earlier, that it works for all sorts of different types of data. And so these ones here are the ones that we particularly looked at. And then we went through a number of specific adoptions. I'm not going to go through these in detail, but just to note that they cover multiple disciplines, multiple different types of data and file types. And these were the early ones, and then there's further ones that were adopted. We're going to hear from this one from Ocean Networks Canada, which, as Andy mentioned earlier, is probably the most sophisticated and full-fledged of all the adoptions. And then there's several that are still in progress. I will note that the Deep Carbon Observatory one is gone as far as it's going to go. That project has kind of ended, and the PI is no longer with us. So the point of this is that if you're interested in this, these adoption stories, I think, are really useful to understand the decisions that people made in different contexts that may be related to you. But I think what was especially helpful that came out of the paper is that we sort of put together lessons learned from all these adoption stories. And we put that in the context of an FAQ, frequently asked questions, because we get these sort of questions a lot. The typical reaction we get is that, oh my God, this is really hard. But what we saw is that people were going into it, that yes, there is some work, and in many cases, people got additional support, like some adoption grants and so forth, to help move this forward. But we also found that even if you only adopt some of the recommendations, you can make a lot of progress, even if you don't adopt all 14. And arguably 13 and 14 have not really been tested yet, certainly not 14 on the migration. And I think that's something that concerns people the most, but it does seem in principle to be work. And the thing I really want to emphasize is that even if you only adopt one recommendation, you have improved the stewardship of your data. Everything that in here is something that you should probably be doing anyway to maintain a well-stewarded, well-curated data set beyond the purposes of citation. So just to go through the FAQs really quick, do the recommendations work for any kind of data? Yeah, it appears so. I mean, we looked at many different kinds. We haven't found the black swan yet. And so, we can't say definitively, but it certainly looks like it works for all types of data. Do you need to update? Do all updates need to be versioned? In an ideal world, yes. But if you're versioning every second or something, and you're not getting queries against your database, then you don't necessarily need to be versioning that every step of the way. The key really is the timestamps. May data be deleted? Andy hinted at this, and again, it's just good archive practice. If you do delete it, you need to say that it has been deleted and where it went. So you may not be able to fully reproduce a query because you have a massive data set and you did a complete new version and you don't want to keep that old data set. You may want to throw that away, but then you at least need to tell the user that what happened. And that's also standard citation practice, a landing page for dead data. What type of queries are permitted? This is kind of a dodge on the question. Any that a repository can support over time, and this is the key. Is you have to be able to support your queries over time. But typically, given the nature of your data set, there's a pretty obvious way to query the data. If it's a geospatial data set, it's space and time. If it's a columnar data set, it's rows and columns. So usually there's not a lot of change in terms of how a query is done. Which PID system can use? Pick your favorite. Use a persistent identity. DOIs seem to be the trendy ones for data citation, but for this subset, maybe you want to just use your own internal handle system or URI or what have you. And then when multiple distributed repositories are queried, this was one of the more interesting ones. Do you need to have some sort of complex time synchronization protocol? No, just make sure that everybody maintains timestamps. Timestamps are really critical to this whole thing. But again, this is often just part of routine archiving processes and that you should be doing anyway, that you should be timestamping when you're ingesting data or deleting data or changing data. And I would say jump in with questions at any time, and same with you folks online. I mentioned this earlier, how does this support giving credit and attribution? It's not something that we really focused on, but we do now allow, the idea is to enable citation of the whole and the subset. And there has been situations where, for example, a group in Australia used this approach for a citizen science data set, where when they queried it, they were able to then credit the individual collectors of those particular observations from that citizen science data set. So although we weren't necessarily constructing it for credit, it does facilitate that in a sense. Credit is a very human concern, and who gets what level of credit is beyond something that machines can figure out. But this helps address that. How does this support reproducibility in science? I think that's obvious. It gets you the exact data used in a study. And does this imply that the underlying data is publicly accessible and shared? No. You still may need to have access permissions to query sensitive data, but if you have those access permissions, then you can run the query. This one comes up a lot. Why should timestamps be used instead of semantic versioning concepts? And there's another session, I think, maybe later this afternoon, or was earlier today, on versioning that's looking at good versioning practices, which is looking at this in detail. But the whole point is timestamps, so that you can go back to that particular time and not get too hung up about version 1.1.3 or whatever. So how complex is it to implement the recommendations? That's probably the biggest question we get all the time. Like I said, people say this is hard. And It really depends on the complexity of your circumstance. When we hear from Raina, you'll see how they're dealing with, I think, a very complex circumstance. And so in some cases, I mean, depending on the nature of your archive, you can probably almost do it out of the box. In some cases, it's going to take a fair amount of work, and particularly if you have distributed data and multiple collections and that sort of thing. And why should you do this if no people aren't asking for it? And this is maybe a little glib, but it's because it's the right thing to do. I mean, this is what we need to do going forward for science. We need to be able to precisely reference the data that were used. And this isn't just for humans. This is really critical. This is really for machines. If you want to be able to have ongoing workflows that reference particular data, then you need to be precise. And so, I mean, I think this is where we need to go as a community in general, is to be able to be very reproducible. So even though it's hard, it's something that needs to be done. So then the overall takeaways is it works, and it's not as hard as it seems. Once you actually get into it, you probably find out that you're already doing a good chunk of what is recommended. And everybody found value in doing it. Even if they didn't implement all 14 recommendations, they found value. They improved their user interface for their users. They improved their provenance. They improved their general archiving processes. So anybody that went through the process found it as a valuable experience, regardless of how far they got. I mentioned this earlier, the technical migration aspect. I don't know that we know of anybody that has actually migrated to a whole new system yet.
We have tested it for schema migrations and some, but we haven't seen any operational complete system update.
Right. So that's still sort of an open question, but I think this is an open question for the archiving world in general. You know, that when you migrate to a new system, you need to make sure that you can still do what was done in the past. I've emphasized this. It's not really about credit, and it's the way of the future. We have to do this if we are going to have verifiable, repeatable data and processive workflows. There's a whole bunch of webinars on the website. I don't think I will go through them in great detail. If you're really interested, we've had a bunch of webinars over the years. I think I've kind of already hit on this, that, you know, identifying, retrieving, and citing the precise subset is a key thing to be done. And it allows retrieving the data to be both as it existed as a given point in time, as well as the current view. So you can change control and change tracking. It even allows you to cite an empty set, which I think is, I mean, it's just kind of cool. And how useful that is, I'm not sure. And the query stored for identifying data subsets provides valuable provenance data. So this is, again, goes beyond citation. This really helps us enable provenance. And we'll hear from Deb Agarwal a little later, talking about a new working group that's spinning up on complex data citation, as it's called, which I think has a fair amount of overlap with this. And this is why we're wanting Deb to present, because we're trying to really make sure that we separate our approaches. But I think in both cases, and in many things, what we're trying to really do is we're trying to get better at provenance. You know, we keep talking about provenance, but actually doing it is really hard. And you're not going to be able to do it without being able to go back to specific queries. It's a useful information on how your data are being used. You know, you can see how people are subsetting your data and what's the interesting bits and who's using those interesting bits. Metadata such as checksum support. Oh, this is the hashing and so forth. Supports the verification, correctness, and authenticity of data sets retrieved. Again, I'm emphasizing this point that it's just helping with good archival practice. And as we keep saying, it seems to work for everything. We have yet to find the black swan. Any questions on the recommendations in general? Yeah, please. Does she need the mic, or do we have an ambient?
No, we haven't.
Okay.
It just occurred to me, if you're managing a research infrastructure, do you need to implement practices to discard like garbage queries? If you get some Autobot to like query 10,000 queries.
Yeah. So the adoption case that I led, the way we did it is the user would, you could query left and right and as much as you wanted, and then once you got to the one you really wanted, then you hit a little button saying mint DOI, or in our case it was mint handle. So that was one approach that we took. So that, because you don't have to save every single query that comes in, so like with bots and so forth. So that, it depends on the particular, scenario that you're in, but that's the approach that we took, that the user makes the decision to say, okay, this is the one that I want.
One of the first operational deployments was a medical data center, and they stored all the queries in a shopping basket, basically. And I guess they even called it shopping basket.
Yeah.
And they had all the queries there, and those queries were automatically purged after 2 months. And within those 2 months, if the research, that's the one that I will finally use, because it usually takes time. You have your 15 different data sets, then you do your research, and then only at the end, you know which data set was actually the one that you were using. So they will keep all the queries in this temporary query store for 2 months. And then after that time, only the ones that you marked as being mint the DOI, those would be kept and the rest would just be purged. But that's then again, institutional policy, how you want to set this up, how long you keep it, whether you do all the queries and say you keep the last one or you have it in a temporary list and give users time to decide.
That's actually an interesting point that we didn't really come out in the slides. The most difficult thing for most of these things was not technical. It tended to be institutional policy changes that were the most difficult things in terms of implementing the recommendations.
I remember we once had a workshop with a partner who wanted to set up this. So we had a meeting with a data curator, the data stewards, and then they pulled in the technical team as well because they were running the database infrastructure. And they were terribly worried about this versioning and timestamping, that this would be a mayhem for the technical people. And the tech guy then said, well, we are doing it already anyway, just because we wanted to be on the safe side if people changed some stuff. We just never bothered telling anybody because we thought nobody was interested. So it turned out that most of the technical stuff was already implemented, just because it is good data management practice to have these versioning approaches anyway. It's just nobody cares about them, but suddenly you could make good use of them.
Yeah.
I think I'm a beginner a bit in this, but it seems to me that you now provide all the answers to the questions that arose in the session for the complex citations. So perhaps you could.
Well, Deb's coming up next to tell us how we did not answer all those questions.
The die now, because they were discussing the fact of the authorship. So if you have different data sets and different authors, and then you have the query, so you assign the pick to the query, but who's the author of that? It's the one who set up the query, or what happens to the authors of the place?
Well, maybe we should hold that discussion after Deb gives her presentations, because she's going to talk about why she didn't feel that this totally worked for her use case, which led to the complex data citation group. And I think, and as I attended that session, and I believe that this is not a complete solution for what they're trying to do there. I think it's a partial solution for some of the use cases, but, and especially since the focus in that group is more on the credit piece than on the reproducibility piece. So yes, I believe that it solves a good chunk of it, but maybe not all of it. And so I think, and that's partly what we're trying to tease apart, is make sure that we're not looking at cross purposes here.
So I have all the scientists in my mind that will ask me what happened to my data set if somebody runs a query on this and then I disappear as an author somewhere. So you said it's not all about authors and credits, but I think it's very important for the scientists. It's the most posed question I have. So what will happen to my credits? And
So basically, we did not discuss the precise semantics of what should be in the author field, because that will depend on the discipline, on the community. Whether the one who creates the query is the author of the subset extracted from a larger data set that has another author. So we linked it, I guess, in our text to the paper that appears in the proceedings. So you have the author of the paper that appears in the proceedings that have an editor. So you have a subset, a single paper that is part of a larger volume, the proceedings, and here, or a journal that runs as a dynamic data set, basically. And here you have a subset created by somebody from a larger set. But then whether you put the data repository, the institution, the group of authors or teams, this is all semantic information. The question then is more, what should go in the citation text that is in a paper? But here we're talking machine actionability. What is in the, I call it the end credits of a movie, because there is like hundreds of people usually contributing to making a data set available, from the measurement to running the infrastructure and the building and everything. So credit giving can be automated, but we don't want to have the end credits for every single data set in a paper, because then there is no room left for the paper anymore. So, but the semantics is not being solved here. And I guess this is one of the issues that many more complex data citation scenarios actually have. But they build on top of, I think they can build on top of this.
So it's your follow-up group, so to say.
Branch out, whatever, yeah.
Yeah, and I think in some cases, developing the query actually is a significant intellectual effort. And in that case, maybe that person that developed the query gets some type of credit. We talked in another session that, maybe they're an editor or something like that. But that is, that's not what we were trying to address.
Would that be like a quality check? Who has a fancy query and who has a very easy query?
Right. No, I mean, sometimes it's a research effort to develop the right query.
Yes.
Yeah. So, but sometimes it's just like,
Sometimes the machine automatically posing monthly queries, basically. Then it's just a routine operations that shouldn't give credit to the machine for running it every week.
I'm just thinking of data sets that just vary in time, and then you could apply this. It's the same authors day to day, and then we have versions also of some data sets, so it stays the same authors and versions every year, and then you could apply a query and the authors wouldn't have any problems.
Yep.
Yeah, no, I think it would definitely contribute, but it won't solve all the problems that the complex citation group is looking at. Any other questions?
Maybe one question. I just wondered, where is the query itself with the bits of the DOI exactly stored? Is it with the data set?
It is at the institution that hosts the data set.
Okay.
And the reason, I mean, the owner, so that the author can store it as well as a copy, but it must be maintained where the data is, because if we ever change the data infrastructure, then you also need to change the queries. So the resolution is with the data set. And in many cases, the query should not even be exposed, because the query shows a lot of technical details about the data infrastructure that some institutions do not want to expose. Having a long SQL string with lots of weird structure. So the fact that it is a query is actually can be completely transparent to the user. We have a setup where users upload CSV files, they're converted into a database in the backend, and they download parts of that CSV file, and it's a query, but they don't know that. They get a CSV file. So this is something that's complete. And actually, I mean, also one issue that we had frequently is that queries as a resolution are a dangerous thing, because who knows whether the query will work. Whenever we are using a file system, we're posing a query, a RAID system that has the file chopped up in many segments across the whole storage and pulling that together. So it's basically what we are doing all the time. File name is, or in the cloud, a file name is a query in basically all storage systems. So it's just applying the same thing that we're using on a day-to-day basis. This is why it's not a mechanism, it's actually a generic principle. There is no particular, how you implement it may differ in the settings, but the fact that we identify something by describing what it is in a technical manner is very generic.
Any questions online?
Good.
Nope.
No,
Okay.
if there's no more questions, then we.
I think Greta's next. And just to note that if you are interested in adopting, please follow up with us. We like to keep sort of a record of adoptions and the lessons learned from when that happens.
Just any work with some of the software well known like Gothenburg, because there are already limitations of versioning of timestamps.
So
any alignment with this?
We haven't been working with Dataverse, so I'm not sure whether they want to implement it as part of the main branch. We have reference implementations for MySQL, for MariaDB, Postgres. They had one reference implementation. Which others do we have? We have one implementation reference for Git, using Git as a versioning system. There is one implementation that stores text indexes, so bag of word indexes for EM25 based textual queries. These are all linked, but if you usually it needs to be adapted to the actual infrastructure. It's not cut in the box. If anybody needs help with that, I mean, that's what the working group is there for. So if you want to run whatever a workshop in order to discuss this, please let us know. We're very happy to accommodate that and help institutions with answering the questions, going through some things in a bit more detail.
Do you run a Dataverse business?
Yes. I
Yeah.
was thinking about that. So
Yeah, well, so if you do, we'd love to hear about it. Yeah.
even the versioning is already.
Yeah, a lot of this
It
stuff.
creates problems, and DOIs for files and versions is.
Yeah, that's why
There are pros
that's-
and cons, lots of pros and cons.
that's why we stay away from this DOIs and versions,
Yes,
because
we know.
whatever is a major or minor change in a data set, how do you denote that? If you correct a typing error in a name in a data set, that means that before that typing error, a query would either return it or not return it differently than afterwards. So you get a different record back. There is no difference between major and minor release in a data set. Any change has an impact on what you get back and thus ruins potentially reproducibility. So that's why we say timestamp every state. It identifies a state of the world. And with that, I hand over to a fantastic state of the world.
So just move the slides.
This is to move the slides, yeah.
Okay.
And here are yours.
Okay, before I get going on my actual content, I just wanted to, I wanted to say a couple points that I jotted down while like the earlier slides were happening about the migration requirements, because I don't really get into them in my slides. So like for me, the migration actually was a really important consideration because we have, first of all, gone through numerous migrations in my 14 years at Ocean Networks Canada. Switching kinds of databases, going from Oracle to Postgres to Cassandra and these kind of things. So, and also I would say is the expansion, like expanding the modes of data access points, especially in how they affect things like the query store, and being mindful that I'm working in an organization with 180 people and about 40 developers who are constantly having their innovative ideas and not really recognizing all the things that they're going to break from one release to another. So constantly being mindful of that. And so unit tests, regression tests around your citation query store infrastructure are so vital. And we put a lot of emphasis on that in our implementation or when we realize problems. So that migration piece is really important. And just like the whole like thought process around it was really, because, persistent identifiers are permanent, or supposed to be permanent. So like a lot of thought went into all of that. So I just think that kind of migration piece is like actually really important to think about. Okay, at least for us. In terms of, just to get started, land and sea acknowledgement. So at the University of Victoria, we're on the land of the Lekwungen peoples, and also in the Songhees, Esquimalt, and Sandwich peoples whose historical relationships continue to this day, but also as Ocean Networks Canada representative who work with many Indigenous communities along the coast. We have to honor and have the great honor to collaborate with these communities on figuring out the coastal monitoring solutions and how we do data management with them. It doesn't really factor into our data citation framework, so to speak, except for giving them the recognition of what they deserve. But for sure, this has been a great opportunity to work with Indigenous nations in our coasts. So the great challenge that we face at Ocean Networks Canada in terms of this whole data citation paradigm and everything we're trying to do is that it's highly heterogeneous. Even though it's all ocean data, well, there's also land environmental data as well, but there's really a variety of ways that data comes in. There's fixed position instruments, there's things that are moving, there's things that are going up and down, there's like over 400 instrument types in our databases, so many different kinds of data formatting and processing levels. Some are autonomous, meaning you collect the data after you recover the instrument. Some of them are real time. We have a lot of cable networks, so we have real time data streams. All kinds of data partners. I mentioned Indigenous, but we also have nonprofit, government, all kinds of partners. And we're constantly expanding our scope. So that's my big worry all the time, is how is this going to hold up as we constantly change and add on different kinds of instruments or modes of data collection. So it's just all the time expanding and expanding. This is sort of a data pipeline in one sense of data. So in terms of our networked real-time data, this is the classic mode, but it's not the only mode. So in this little diagram, it shows the instruments on the left, where they're talking to drivers, which is the software that's sending commands and gathering the responses back from these instruments. Then it's passing it down the pipeline to be parsed, calibrated, automatically QA/QC'd. That data sometimes has events that are detected based on them, like earthquakes or tsunamis. The data is, of course, archived, both in terms of the parsed data and the file-based data. We have post-processing that happens to derive products of different sorts, some of them fused from more than one instrument. And then, of course, that all goes to the users. So, and then that's only one mode. We have all kinds of different ways data comes in. In terms of our citation framework, this was initially developed through a project called Minted that was funded in Canada by Plenary and Research Data Canada. And so that was initially to develop our citation framework using the recommendations from this RDA Data Citation Working Group. And so basically we had to expand. So this blue is representative of our Oceans, we call it Oceans 3.0 digital infrastructure. And so in that project, we added on, that's where we added on all the citation framework that we have today. And it includes RORs for recognizing of organizations. We didn't focus yet on ORCIDs as individuals, but that's something we have yet to do. It's mainly because we partner mainly at the organization level, and that's who we're trying to give the credit to. But of course, ORCIDs is something that we need to work on as well. And so, yeah, we're trying to just make sure that we have all that connectivity with both DataCite and ROR and hopefully other identifier systems in the future. So then most recently, we had another funded project called DynaCite, and this was about training and education. So you develop this magic system, but it has to be used by the researchers and also the partners who can help to contribute data sets. They need to understand it. So we had this last year opportunity to have workshops with those users, develop more documentation, understand what are we doing right, what are we doing wrong, what are they confused about, what they're confused about a lot of things. But we had a great opportunity to kind of work through a lot of that and are continuing to develop more resources and materials for them. And then now we're working on what we call the experimented project, kind of the idea of like, we've had this experience and we've done these experiments. And now we're continuing to push the boundaries and to add more features and functionality to make it a more fuller and flush system, and also to account for, since we first went about implementing it, there's been evolution of what's best practice and what's available as services. So just trying to leverage as much as we can. For us, this was a big starting point in terms of what granularity, what is the data set? So we decided for our purposes, the best thing to do to account for all the different notions like crediting, like versioning, like just the way our infrastructure was set up, that we decided that one deployment of one instrument and the data captured from that is one data set, and that includes all the different formats that we might offer within that deployment of data. So that's what we went with. And then we also had to realize, hey, we have thousands of data sets. We can't manually mint and curate metadata for all of these data sets. So we put a lot of effort into automation. So automating the titles and abstracts based on other metadata that we're already curating. And so the titles, for instance, get automated. The abstracts get automated based on a little format, nice. Pulling metadata out of bits and pieces that we have elsewhere. And I don't actually have a slide for it, but we're also automating the minting itself. So basically what happens is we deploy an instrument physically in the real world. The data stewards start to curate the metadata, like where did it get deployed and when, and fill in all the metadata to describe that deployment. And then there's a piece of code, a daily job that kind of checks, hey, does this deployment have a DOI already? And if not, does it have all the metadata filled out already by the data stewards in order to, that it needs to put into DataCite? And so if that all has been filled out, then it means the DOI and the data stewards do have a step in their workflow within the commissioning phase of a deployment to verify that the citation information looks all correct. And if not, they can version the metadata. Like let's say they put in a coordinate for the latitude and then realize, oh shoot, that was a typo. They can still edit that location and do a metadata update manually right now, but we're moving towards automatically detecting those changes and just updating the metadata automatically as well. In terms of the query information, this is the screenshot of one of our access interfaces called the data search, whereby the users can select the type of format they want to download, parameters for the products, like do they want the data to be averaged like in a minute level, an hour level, or not averaged at all? Do they want it cleaned? Do they have all these different choices? And depending on the product they choose, they have different choices. So every time they click a box, this data product options will show up about what's available as options for that particular product. And the green information of options changes depending on what you click on above. So, and they can pick particular variables, like in this is a fluorometer that has chlorophyll and turbidity. They can get both variables at a time, or they can choose only chlorophyll, only turbidity. They can choose the time subset they want. So they have all these different dimensions along which they can decide what it is that they're actually wanting to download.
Is there an API for all that too?
There is an API, like a web service that's available to end users that replicates exactly what's on the screen. So yeah, so that's available as a web service as well. And then when that actually gets stored in the query store, we identify not only the query information, but also the source. Was it the service, or was it this UI, or what was the access point? So we keep that as well. And then, so let's say, so now they've got they've done their query, whether it's this web service or the UI, and then we put this into the query store, and we do actually save every query. We don't just, we don't toss any over time, and we don't have the user select, we keep them all. And then then there's this query pit, which is a local, in our system, a local query pit, and we eventually will move to a data site DOI or something, but right now it's just a local pit. And then, but it resolves on our page, and we have a web service that it can resolve it as well. But on the landing page then, so on the left-hand side is kind of the standard data set metadata, the most part, and then on the right-hand side is this query details when you resolve it with the query pit. So you get basically all the things you've selected, the time range, the data format, the data product options, etc. So that kind of retrieves all that information from the query store and displays it. So the piece of pie from the entire pie that you chose. And then one thing that we recognized from our experiments is that users don't necessarily, when they go to publish, remember what they're how to find what was that they actually searched on to get their query pit again. They can't necessarily find the right files or whatever it is that they originally downloaded. So we're developing this tool that's now just a prototype right now. It came in our most recent release, but we haven't really advertised it yet, and it's only, we're working on some performance little issues, but basically we're developing a new interface whereby the users can come onto this search history page and see all their historic queries over time that they've done. And it gives them like a little thing you can click on to get the citation text that they can use in their publication. And we do hope in the future to further enhance this by allowing some kind of like clickable, like I want to choose these 5 queries I did and combine them into a self-curated collection that they could use for, and then we would mint a DOI at that moment at a collection level so that they could streamline their citations for publishing purposes. But so that's all coming. In terms of the versioning of the data, we developed what we call this batch system. It's just our term for it, but a batch for us contains 3 elements. It's the triggers of why, what's the cause of why we need to version the data versioning itself, so the reprocessing that we need to do once that metadata or those triggers have happened, and then the DOI, the new DOI minting and having those relationships between the DOIs to say that one is a version of and the other one is this previous version of and this new version of, and the data site metadata gets updated at the same time. So there's a variety of things that could trigger need to reprocessing. We might realize, oh, the calibration formula was wrong, or maybe a coefficient was entered incorrectly, or manufacturer revised what they gave us, or all kinds of things around calibration formulas happen all the time. We could be deciding that the data product parameters don't make sense, we need to revise them. It could be that there was an error in the parser, or we're extending the parser to be able to pull out more of the raw data contents. And then versioning might be reprocessing that raw data at the parsing level. It might be repost-processing on some of the derived products. And it might be that we are able to fill gaps later on. So an example of that is we have this case with due to military sensitivities with passive acoustics, whereby they actually will take data away from us in real time to look at seeing if they need to redact it for their military sensitivities, and then they give it back to us later if they see nothing, or sometimes we never get it back. But when we get it back kind of after the fact, that's kind of one of these kind of cases where we're filling data in later. But there's other reasons for that too.
So the timestamps will reveal when there was data that
We have timestamping on all kinds of things.
potentially contains redacted data.
It's very confusing. But we have timestamps on every single thing we do. It's everything. And then that version history will show on the landing page. And it'll highlight the line of the page that you have actually resolved. And it'll say what is the reason for why the data is versioned. Now, one thing that we want to improve here is a little bit more information about those details of the triggers and the versioning that was done alongside that reason. We do have it, but it's hard to interpret as an end user, and we'd like to make it more interoperable, maybe using the prov ontology, but that's not there yet. So collections, a lot of conversation around collections. And so this is one thing we're building capacity on for ourselves. So we've started this process right now where we're manually creating collections that are needed, leveraging the data site collection resource type, and the has part is part of relationships between the two. So that's very manually right now, and there's different use cases that we have. So one use case is around when instruments are kind of like you might have all data sets on one particular platform, like on a ship or on a seafloor bottom platform. You might have, alongside this, you might have, because I said a data set for us is one deployment of one device, but most of the places that we have instruments, we will recover that instrument and put a new one down in its place that's refurbished and with an updated calibration, because the instruments have to go back to get calibrated, and but they get replaced with another to have this ongoing long-term time series. And so we would like to stitch together those data sets of the same instrument type over time, and so that's a use case. And we already have the metadata in our system to account for that stitching, but just not the associated DOI collection. So that's something that that's one of the main use cases. And then another use case is like when we have these stations for where they do CTD cast, so where they do a instrument that collects conductivity, temperature, depth, and maybe other parameters, and it'll just go profile down and up in one station location. And so for us, so that's called a cast. And so for us, each cast will have a DOI. That's what we're actually working on right now, is getting those cast DOIs. But because that infrastructure was being developed at the same time as minted, so we're doing it now. But anyways, so one cast will be a data set with a DOI, but all casts at a station would be a collection. So that's what we're moving towards. And then another, the famous one that's talked about in that complex citation working group is the user requested data collections, where they need to kind of compile customized set of data queries and data sets. And so that's one thing we've been working on the manual generation of to support these researchers. And so this is one example that we've done for alongside a paper that one of our researchers wrote, and we put together a collection. DOI, and they basically goes alongside with the paper of what they used from our repository. And so what we hope is that this will get replaced by that search history tool where they can select it themselves and we're not having to manually do it with them. So now we're working on this experimented project, as I mentioned, and we have 8 goals. And this is in progress already, but it will probably last, I would say, probably at least another year, maybe longer. And in this one, we're still working towards making this DOI query metadata much more obvious to the users. I said the search history tool is one way. We have other ideas, but that's the one we're focusing on first. The other thing is this versioning system. There are, while it is fairly robust and comprehensive right now, there's a few more use cases that it doesn't adequately handle in all the ways that we manipulate data. So we want to improve on that. And alongside that would be number goal 3, which I mentioned about having that provenance information while we capture it. It's not necessarily adhering to best practices in terms of how it's displayed or represented. And also we'd like to integrate what's on the landing page into the ISO, our metadata records, our ISO 19915. So that's something that will be happening, and hopefully just make that more clear to the end users. The 4th goal is around the landing page enhancements, so that there's richer metadata. So embedding schema.org so that it's available through the Google search. We're working on those requirements now, and putting in just more usability information, like we give the information of the bounds that are in the data site metadata of like the latitude, longitude, but we could have a map. There's just ways to make it more, more rich for the users. Goal number 5 is around leveraging more of the data site metadata schema. We're using, of course, all the required fields and some of the optional fields, but there's more we need to do. And one thing that we've been working on a lot over the last couple months is the relationships to publications. And we're going painstakingly, and my data stewards are not very happy with me, but they're painstakingly going through historical publications and trying to figure out what data sets were used by those researchers so that we can check back with them and link them up. It's a good exercise because it shows how difficult it is, because these are the data stewards that curated the data in the first place. They know the data like better than anyone, and yet they can't tell oftentimes what the researchers actually use, like they didn't describe the location well enough or the time frame well enough or anything well enough, and so they're stumbling around with, well, did they mean this or did they mean that, or so yeah, it's really interesting. So but the end goal there is to go to update all the records with whatever we can to maximize the PID graph and also display that on the landing pages. And then goal 7, that's the collections I mentioned already. And goal number 8 is just enhancing more and more, like actually around the migration stuff, to make sure that we're monitoring for changes or issues over time better than we are today. That's all.
Thank you. Questions?
We don't have a lot of time.
Yeah, I guess.
Yeah, no, we gotta get
one or two questions.
So I'm interested in choosing the identifier, especially the DOI suffix. So in your presentation, so you are using UUID for DOI suffix, but sometimes the researchers want to include their version number in the DOI prefix. And I'm interested in whether there was a discussion about choosing the DOI prefix.
The DOI prefix is just our organizational one for data site.
So he's saying
Suffix. Sorry.
Oh yeah, so we're that's. I think we're actually just getting it on the minting. We're not.
But it looks like it's a UUID.
Yeah, it looks like
Yeah.
that. But no, we're not letting users have any influence whatsoever on that, and no one's requested that. So.
I think general practice is to avoid any sort of semantic
Yeah.
information.
Yeah, we want to
DOI.
avoid meaning inside of that. 'Cause
Yeah.
then that's where you get around that's where you run into migration problems.
Yeah, but sometimes the researchers don't want to use the random identifier. They want to use yeah.
Semantic should be in the metadata, not in the identifier.
Yeah.
I guess it's one of the few mantras that turn out to be right again and again as soon as something changes.
Yeah.
And I think that's one of the myths that we encounter is where that like lack of understanding is that researchers don't see the DOI as more than just that little string of characters. They don't understand the metadata being all attached to it, and also the responsibility that a repository takes to maintain that information over time. So they just think you could slap a DOI or hand them out DOIs, but
We should go to Deb.
Yep. So we hand over to Deb for the next presentation.
We can go over these. Oh, she said.
Yes. Do you want to share screen or shall I just click onward and you start talking and I'll keep sharing the screen from here?
Yes.
I think the safest, that would be the safest thing.
Okay, so.
I'm sitting in a hotel lobby, so apologies if you hear music in the background.
Maybe
I don't know how to. Just say we're just putting up the loudspeaker a bit more loud.
Oh, okay.
there is
Well, I am down in the lobby, so I can speak louder.
There.
Can you hear me now?
We can hear you, you're just a little soft.
try one of these.
Okay.
But no, we're working, I think it's on our end. I mean, you're clear, we just need to amplify you.
Okay.
more.
I mean, because I could try shifting to the computers.
No.
I could try shifting to the computer's microphone.
No, the microphone is fine. It's just that the loudspeaker here is a bit silent. But I guess we can hear if we are all silent.
Yeah.
Breakout. Go ahead.
Okay, so apologies for those of you who were in the prior session. I'm going to use the same slides, but I've got a very different set of speaking points to it. And I know it doesn't, when you look at dynamic data citations, you say, well, why do I need complex citations? Why is that a separate working group? Why isn't this already covered? And so I want to speak to that. Shelley should also be there in the room. I'm not sure whether Martina also made it.
No, neither one did.
Okay, I'd like to be able to answer those questions as part of going through this. So go ahead into the next slide. So just to sort of set that context, when we're thinking about the complex citation, we're really looking at the case where licensing and other realities of that data required citation. And citation is then causing that there are greater than 50 and up to millions of resources that you're needing to cite in a paper. And that typically those resources are coming from many different repositories and not just a single one. And in this case, most of the data I've ever dealt with ends up it's CC by 4. And where the acknowledgement requirement is a citation. So that's one of the issues with thinking about how I would use dynamic data citation, even in a single repository, because it's unclear whether I'm meeting that citation requirement if I'm giving them a new citation that actually obfuscates which data was used down to a level where they don't have a direct citation. But I'll get into that in a minute. So I think most of you have probably hit this already, which is one of the reasons for dynamic data citation, that publishers just aren't allowing a lot of data citations, and they're just asking for them in the supplementary material and other places, and or are asking us to not even cite the data, which we have actually seen those requests from publishers on a regular basis. So next slide. So I want to start with just a really simple use case where it is all in the same place, and where we were looking at dynamic data citation as one of the ways we could enable citation of the data set. And so that's FluxNet 2015. This is a global carbon flux data set. And what you see in this global carbon flux data set is that, did we lose the slides?
Just stopping sharing to turn up the volume, but.
Okay, so you're still having trouble hearing me.
Okay,
So you have to share it again.
Yep.
Or probably her mic in the other end.
It's fine.
Go ahead, Deb, it's all right.
Okay, so in this FluxNet 2015 data set, there are 212 underlying data sets that are part of that. They're all in our repository, and they are all generated by independent teams who've spent, anywhere from 1 to 25 years building their individual data set. So these aren't one deployment of one instrument. These are an entire site team over a long period of time. So they definitely want their citation. But we were still looking at it because we know that they're not getting them anyway because they were ending up with supplementary materials. And so we were looking at using dynamic data citation, where for us, a query would be a simple list of sites. And one of the things that really stopped us, so two things stopped us. The first was the CC by 4 license, which said, they were requesting citation as their acknowledgement, and therefore it was unclear. But I thought I could overcome that because I've generally had a good rapport with all of the sites. But the other issue for us is that they don't start out with, generally the user is going to come in and download the entire 212 data sets as their download. And then they're going to go through and figure out which subset they're going to use. But I thought I'd solve that too, because I was going to then have that they come back and tell me what sites they used, and then we generate the query at that point and save it. So we were pretty far down figuring out how we were going to do all these things. But the final thing that really stopped me from using dynamic data citation for just this particular repository is that we're very project based. We're specific to this carbon flux project, and we've already seen this project evolve over time and not be ours. Early in its life, it was administered by another laboratory. It's now administered by us, and we were very concerned about building a technology deficit for whoever took over after us. And we didn't feel that there was enough gain from dynamic data citation, given all the issues with the citation, to actually use it. So within this individual repository, that was what stopped us. But now, so go on to the next slide. So in that particular case, what we ended up doing is actually deciding to write a high value paper. Because with a prestigious paper, we were able to have the citations of that paper, if they had authorship on that paper, would make all of the sites happy if users cited that paper. And that's the big difference between the dynamic data citation or a collection and this paper solution, is that collection, it doesn't have high prestige. The dynamic data citation definitely doesn't, because it's only used by one paper. So for the teams that provided the data, it was enough of an obfuscation for them that they didn't consider it to be a citation for them. So even if I was going to figure out all the apparatus to be able to count all of these and find them all and try to count up their citations based on those, but that amount of apparatus for a small project with a very small data team was really not an option. So go on to the next slide. I want to leave plenty of time for us to actually discuss things too. But that paper really worked. I mean, that was a useful solution. It's not a common solution for us because of the fact that we're moving to regular releases, and it took us 4 years to generate this paper. Because it turns out the publishers are not very conducive to writing data papers or any other kind of paper based on data, because they want tons of new unique content that's never been published anywhere else. So if the data set has already been published, even just in your repository, that they actually tell you that you have to have new content, new data before you can publish it as a new paper, which was really annoying. But it added several years to the time to make the paper. So next slide. So we have a lot of use cases, but what I want to do is go back to the criteria. So next slide. So in here, the other thing that happened for us is that at the same time I started running a repository as well, and I started working more with some very large scale projects. And in these large scale earth science projects, we're pulling together data from many different sources, and starting to look at things like, you know, what is the overall climate change impacts in a watershed or in a region, and where you're pulling together data from 5, 10, 15 different repositories. And now when you think about dynamic data citation, there's nobody to implement that dynamic data citation across the 15 or, you know, however many repositories, and provide that kind of capability. And it's not even clear that it would be feasible from the sense of the licensing aspect. Because I do find that a lot of these repositories will have a CC by 4 type license where citation is required. So at that point, and I do have a paper about this. I don't have the citation on here. I meant to. But basically what we found is that at that point, you really do have to cite each of the individual resources that you use, and you hit this 50 citations or more in the system. And this gets multiplied when you think about samples as well. So what we've been looking at is really the fact that, you know, at that point, I don't know of a way to use the dynamic data citation for this. So that's when we started to come into the complex citation problem and to build up this working group. And I don't want to say dynamic data citation, I love them, right? I mean, this is not something where I said, oh my God, I don't like these things, I don't want to use them. I like them. And I think they have a huge use case, particularly for well-established large-scale institutional repositories. Because you can actually build all that apparatus and track it and enable that and have some confidence that you are the long-term location where this data will be, right? Whereas in my case, I have confidence that this data will be maintained long-term. I don't have confidence that it will always be with me. I have 2 different repositories where I took them over from another institution and had to modernize them from where they were, and where they had a lot of custom implementation that provided the users a lot of benefit. But in looking at it, I would have had to build a lot of antiquated hardware to maintain the thing that they had. So I'm also really careful with my repository of not wanting to provide a technology deficit to the next people who take over the repository, 15, 20 years from now, whenever that is. So those are some of my driving elements to this, but the CC by 4 is the other key element to this. And so that's what's driving the complex citation, and that with complex citation, when I look at it, I say, well, okay, what I need is a way to overcome the deficit that the publishers have given us, where they have this paper concept and they feel like, oh, you know, it's got to fit on a page. The references, the citations have to fit on a page. And so the idea of complex citation is to enable us to have some sort of a bucket, you know, we're calling it a reliquary, where you can put all of those citations, those references, and have them able to be directly cited in a paper in a way that is counted or thought of as a citation to that specific data. And the reason why I want to still be able to be specific into that location is because you want reusability. You want to be able to have that the reader of that paper can determine exactly which data was used. And if I turn it into just a collection or some form of a dynamic data citation, the user doesn't have the ability to make specific reference and citation of which data of that overall set was this part of the paper talking about. And in our case, that's been really important. And so those are some of the reasons why dynamic data citation doesn't work at this scale and in this particular type of challenge. And we imagine that many dynamic data citations would be part of the reliquary, because I might have gotten something from Ocean Canada where, you know, that's one of the data sets that I used in my study, and therefore it's a dynamic data citation that's one of the things in this reliquary. But the whole idea of this is that then in the reliquary, once you've built this special version of a collection that is this reliquary, that you would be able to cite those individual elements, and they'd have PIDs that allow you to say it's in this reliquary and it's this particular item in the reliquary, or these particular items in the reliquary. And that's the main thing about this that makes it very different. And it's sort of the higher order problem, because we keep going up in scale in terms of what we're trying to do. And you know, so I've done the same thing where, you know, I build collections where there's, you know, when I look at any individual FluxNet site or, you know, they have tons of different campaigns they've run, different things. In reality, I should have hundreds of DOIs for that that individual site. What we've done is we've just given them one DOI. So they've already turned into a collection at the first level. Going up to the next level and turning them into another collection is challenging for them. But that being said, I think that's that core idea of the reliquaries from my perspective, is this fact that what we're trying to do is just, if we just take it down to its base level, we're trying to enable that you could have had in your reference section of your paper up to 1 million references, and it would have been fine. And the way to do that is this, having an electronic reliquary that you can use as your reference section. So it's almost a bibliography, like a BibTeX bibliography or an EndNote bibliography. And so think of it that way as what we're trying to do. And then some of this all makes sense, because you can then think about it as oh, okay, it's not about the same problem.
Sorry, we need to cut short because we are at the end of time. Can I just just because we got a point. I mean, there is little time to discuss now, unfortunately. From
Sorry.
That makes perfect sense. I think what we are talking about is two different layers. One is how you identify the relevant data in question and how you then represent it, because that's what your discussion seems to be focusing about. So out of the gut, I only have two quick comments. I think the reliquary is a very viable way of representing the information. How you identify it, whether you materialize it or dynamically identify it via query, doesn't really make any difference, because that's just a technicality in the background. And our solution really is only very, very limited to the technical level. So the reliquary then is the representation that then points to. Mark mentioned the case study was done in Australia by Jane Hunter, I guess, in one of the early phases of this working group. where she was having a citizen science project, was bird songs or some recordings that were contributed by citizen scientists. And again, they wanted to give credit to all the scientists who had contributed even just a single recording to the subset selected. That was done via such dynamically resolved queries. And whether you then put 10,000 names into a paper or via a reliquary or separately is a representational issue. The other question on the complexity of the technical infrastructure, we had a use case, that's the VMDC, the Virtual Atomic and Molecular Data Center, that also was a distributed repository where not all the distributed sites were implementing the full timestamping. So what they had was simply a wrapper centrally where the query node was, where the query was being processed, and that managed the timestamping when the query was being processed for the individual nodes, so to speak. So I guess there is, we need to separate between a technical solution that is all about referencing and resolution and a representation layer of how is this shown and depicted to the user, reflected in a paper, reflected in the citation text that I understand is something that we haven't addressed at all. So there is definitely room for a lot of discussion, and I think also communities will differ a lot depending on the specific needs that you were describing from your use cases. And so sorting these out, how they can be addressed, how they can be accommodated so it fits the community needs and the respective publisher regulations in that community, because they also differ across communities quite a bit, is something that definitely is worth discussing. What would be interesting from our perspectives is to see whether you find any aspect where the technical implications of the principles of timestamping and versioning the data and identifying subsets via a query would be limiting to what you want to try to achieve on top of it. That would be something, if you identify such a case, that would be really very interesting for us, because that would mean that we would either need to amend the recommendations or see how we can find a solution for that one. So far, just from, but this is very surface level view, it seems to align very nicely in that respect.
Well, and so I think the takeaway is that we will participate in your working group and see where those intersections go. And the point about licensing is well taken. And so my point on that is that if anybody's listening, CC BY is not appropriate for data. You should be using CC 0, but I'll just leave that there.
Good.
Thanks, Deb. Sorry we cut you off. We spent too much time on the intro. We probably need to separate these things out more.
No problem.
Gets us to the end of the session. Thanks a lot. I hope you found it useful. If you found it useful, let us know. If you have any use cases, adoptions, or if you see any issues like the ones that we just raised and discussed, we'd be very interested in learning from you. There is new directions that we are moving on to, is taking a look at versioning online learning systems to identify states of the world there. We might get a presentation next time on how this data versioning is being applied in metadata settings. So data management plans, for example, are being versioned and timestamped as the metadata evolves, which is exactly the same principle. So just to see the breadth of the scope, what was the view on a data management plan at a given point in time? How did it change over time? Things like that, so that we get a broader picture of where this, it's not just data citation, which is this identifying a state of knowledge at a given point in time really applies. And so we're looking forward to hearing back from you if you have any other similar settings, crazy ideas of where you would want to apply it, or things where you think it might be difficult to apply. And yeah, let us know if you would like to come again for the next adoption session in Salzburg in end of October. Looking forward to seeing you again. Thanks a lot.